Hello, today's lecture is about annuity. The word annuity means that we have a series of periodic payments that are made in equal amounts. These payments are made at equal intervals of time. So I will have the same amount, maybe yearly, monthly, quarterly, but the annuity refers to periodic and equal amounts. Let's see how do we see it on the cash flow diagram. You will see that it is the same equal amount and it's made at a periodic interval of time, at period 1, at period 2, at period 3. So if I'm having consistent payments of equal amount. So usually the annuities will not begin from period 0 because this is the present value. We usually have the first amount at year 1. So this is referred to as the annuity. Let's look at an example here. Suppose I have an amount of $10,000 at the end of year 1, the same amount at the end of year 2, 3, and 4. So it's the same amount, equal amount, and it's taking place at the end of each year. So this is how we realize that this is an annuity. Now again, we want to use the calculations related to the time value of money, and I want to get the future equivalence of this annuity. To find it, we will have an equations for it. F equals A into 1 plus I to the power n minus 1 over I. And in the same manner that we used before, we can replace this part of the equation with the factor. So I'm calculating here the future of the annuity. So I already know the annuity and I want to get F. So F equals A. When I open the bracket, it's going to be in the same sequence. I'm getting F knowing A. So F comes first. F knowing A, I n. And I have to get the value of this factor from the table of interest. So the form of the question will come in this way. How much will you have in 40 years? So after 40 years, so I'm asking about the future. If you save $3,000 each year. So this is the key word that will tell you that we're talking about an annuity. It's happening each year, the same amount of money. So this is an annuity. So right away you will say A equals to 3,000. And we are earning 8%. This is the interest rate. So I'm calculating F. F equals A into F knowing A, I, and N equals to 40. So what do? We go to the table of interest, get the F knowing A at N equals to 40, multiply the value with 3,000. So the future value of $3,000 saved each year for 40 years. After 40 years, this amount will accumulate to become $777,000. Now, if we look at the table of interest, previously we have been dealing with single amounts, only one amount. I'm getting its equivalence in the present or the future. So I was dealing with these two columns. Now, if you look here, these four columns are related to uniform series of payments that are taking place at the end of each year or each month. Okay, so these four columns are related to annuities. To finding F given A, to finding the present given A, to find A given F, to find A given P. So in the previous example, I was finding F when n was 40, so this is 40. So I look at the intersection of this row with this column. So this is the value of the factor, the value that I will get out of this table. In the same way, if I want to calculate the present value of an annuity, the form of the question will come like this. How much money is needed today to provide an annual amount of $50,000? So you see, annual amount of 50, so this amount is the same each year. So I know that this is my annuity for 20 years, so this is N at 9%. So how much money is needed today? So I'm asking for the present value. Now again, we have an equation to find P, knowing A. This is the equation. You do not have to memorize any of the equations. All of these equations will be given, but it's easier at this point of time because the equations are getting more complicated to use the factor right away. So I will be saying P equals A into P knowing A IN, and I get the value from the table for N equals to 20, and this is the intersection with the P knowing A column. So you will see that the present value has to be this amount. Now again, if I want to calculate A, knowing F, how much would you need to set aside each year for 25 years? So I'm asking for the annuity to have accumulated $1 million at the end of 25 years. So you see, it's the same idea. You just get the value of the factor from the table and multiply it by the future value, which is in this case the $1 million. This is the final answer. Now just presenting how the form of the question comes, just to get used to it. So here I'm saying if you had $500,000 today, so this is the present value, in an account earning 10% each year, how much could you withdraw each year? Again, so you have to look at the key words in the statement. So here I'm asking for the annuity, but knowing the present value, so I'll be applying the equation of A equals P into A knowing P IN. Now I just want you to have a look at this idea. What if I want to continue solving using what we did in the last lecture, which is dealing with all of these annuities. I don't want to treat it as an annuity. I want to treat each value alone as a single value. Can't I get its equivalence in the present or the future? Will it give me the same answer? Let's see together here. You wish to withdraw $10,000 at the end of each of the next 4 years from a bank account, paying 10% interest rate. How much do you need to invest today? So I'm asking for the present value, and I know that the annuity is $10,000, okay? Or I'm having this $10,000 at the end of each of the next 4 years. So when I draw the cash flow diagram, you see that I have $10,000 at year 1, 2, 3, and 4. Now, with the method that I have presented now in this lecture, we can get the present value of this annuity right away in one equation. But what if I want to treat each one of these amounts as a single value? So I will say that this is a future value and I want to get its present. This is a future value, I want to get its present. So I'm splitting these amounts into single amounts. Will this give me the same answer as when I get the present value right away by considering that this is an annuity? Let's see. If I look at the table of interest and I want to treat each one of these $10,000 as a single amount in the future and I want to get its present, so I will be saying P equals F into P knowing FIN. So these are the values that I will be getting from the table for year 1, 2, 3, and 4. Okay? So if I want to get the present value of the following amounts being splitted, you will say P equals F into P knowing FIN. This is the future value F, and this is the value of the factor from the table. So I will be saying P equals F, and this is the value of the factor P knowing F. So if I want to get the present value of this amount, I will just multiply this one by this one. This is the amount. And if I want to get the total present value of these 4 amounts, the amounts will be 31,698. If I sum up the factors that I got from the table related to the column of P knowing F for the first 4 years, it will be 3.16. Now, if I go back to the table related to P equals A into P knowing AIN when n equals to 4, what do you notice? The value of the factor is 3.16. So this proves that if you want to get the present value of an annuity of 4 years, using the equation P equals A into P knowing AIN, you will get the same answer when you get the future value, the present value of these future amounts to the present and then add each one together. So these methods will give you the same answer. But because we don't, let's say I have annuity of 10 years, instead of getting the present value of each one of these amounts alone, then get the summation, it's easier to do it in one step using the equation related to the annuity. But I just wanted to show you that they both will give the same answer. So you see, when you want to apply the equation P equals A into P knowing A, I4, P equals A, this is the annuity A, 10,000. P knowing A, I4, it's the value that we got from the table related to the annuity of 4. We were looking at the column related to P knowing A, and the amount was 3.16. So you see we got the same answer. Now I just want you to check these tables here just to mind the way we ask the question. For example, here to find a single cash flow, here I'm finding F given P. The question will come in this form: a firm borrows $1,000 for 8 years. How much must it repay in a lump sum at the end of the 8th year? So I'm finding F, knowing P. Or I might be saying, what is the future equivalent at the end of 8 years of $1,000 at the beginning of those 8 years? Okay, or for example here, related to finding F knowing A, if 8 annual deposits of 187.45 each are placed in an account, so this is the annuity, how much money has accumulated immediately after the last deposit? So I'm asking for the future. Okay, just have a look at this slide and the following one, this one, just to know how the question comes, the form of the question, the form of the writing, just to get used to understanding the given and what's required. For example, here, what is the size of 8 equal annual payments? So 8 equal annual payments, I'm asking for A, to repay a loan of $1,000. The first payment is due 1 year after receiving the loan, indicating that this is the annuity because the annuity will take place 1 year from the present. This is what I need you to know regarding the annuity. Next time we will solve exercises related to annuity. Thank you.